In this video, we'll study collisions in 2 dimensions, learning how to calculate their variables. Have you ever played billiards, marbles, or snooker? In games like these, 2 objects collide and the result is a change in their directions and their velocities. A collision is an interaction in which 2 objects interact by means of some force. According to the conservation of momentum, the initial and final momentum are the same before and after all collisions. When a collision isn't head-on, but objects collide in 2 dimensions, their momentum is conserved in 2 directions. Say 2 objects, mass 1 and mass 2, collide. Since momentum is always conserved, the mass times the velocity of object 1 plus the mass times velocity of object 2 is the same before and after the collision. v1 and v2 represent the respective velocities of the objects, and m1 and m2 represent the masses. The easiest way to calculate the components of momentum in 2 dimensions is usually to consider momentum in 2 perpendicular dimensions. Momentum is conserved in both the x direction and the y direction, represented with the subscripts x and y. Now imagine a game of pool or snooker. You hit a ball, ball A. It collides with a static ball, ball B. Ball A moves at an angle θ above the horizontal line, and ball B moves at an angle φ relative to the horizontal line. Starting with the x direction, we can say that Pix equals Pfx. That is, the initial and final momentum in the x direction is the same. Therefore, mass times initial velocity for ball A equals its mass times final velocity times cos θ plus mass times final velocity for ball B times cos φ. Similarly, momentum is conserved in the y direction. Initial momentum is equal to 0, so 0 equals m1 v1 f sin θ minus m2 v2 f sin φ. The final momentum will be negative for m2, since its final velocity is directed downwards. If the collision were elastic, all kinetic energy would be conserved. Ki, the initial kinetic energy, would equal Kf, the final kinetic energy. That means a half m1 v1i squared equals a half m1 v1f squared plus a half times m2 v2f squared. On the other hand, if a collision in 2 dimensions is inelastic, then by definition, kinetic energy is not conserved. Ki does not equal Kf. Don't forget to consider both the x and y directions of velocity when calculating the momentum conservation. Let's try applying these equations to an example. Consider 2 billiard balls, A and B of equal mass. Ball A moves in the plus x direction with an initial velocity of 4.5 meters per second and strikes ball B, which is initially at rest. After the collision, ball A moves at an angle 45 degrees above the x-axis, and ball B moves 45 degrees below the x-axis, as shown in the figure. Determine the speed of the 2 balls after collision. Pause now if you want to try to solve the problem independently. First, we know the initial velocities of both balls, but we need to determine the final velocities. Apply the conservation of momentum along the y direction. Again, since the masses are equal, we can cross them out. Simplifying tells us that the final velocities of the 2 balls are equal. Next, apply the conservation of momentum along the x direction. Since the balls' masses are equal, we can remove them from the equation. Simplifying and reshuffling gives us the equation for the final velocity of ball A, 3.2 meters per second. Since VAF equals VBF, the final velocity of ball B is also 3.2 meters per second. We have learned about collisions in a 2-dimensional plane and some equations for calculating the mass and velocity of the objects involved. Thanks for watching. If you found this animation helpful, subscribe for more.